So we have Captain Rahul Chaudhary, who is the Managing Director of Veritas Petroleum Services from Singapore. Welcome to the panel, Captain Rahul. Then we have Mr. Pawan Kapoor, with 4 decades of experience in the maritime industry, former head of International Maritime Training Center and CEO of Tolani Maritime Institute. Now he has founded this ISF group, which is involved with training, e-solutions and applied research. Then we have Mr. P. Jairaj Kumar. So we have Mr. Girish Sriraman, who is the Area Manager Maritime for India, Bangladesh and Thailand from DNV GL Maritime. And we have Ms. Vinitha Venkatesh, who is the Managing Director of Ocean to Door Private Limited with 2.5 decades of experience in the shipping industry. Then we have Mr. Christian Morgenstern, who is the Superintendent Engineer Marine from MAN Energy Solutions. He is joining from Germany. And then finally, let me introduce our moderator, Mr. Indranath Bose, who is the advisor to the Great Eastern Shipping Company Limited. Thank you, Mr. Bose, for your patience and accepting to be on both the panels. Now you have the responsibility of moderating the session. I hand over the session to you.
Thank you very much. A warm welcome to the second session. So we have glittering personalities here, all very well known in the industry. Mr. Ramprasad has already introduced each one of them. So what I will do, I will continue with the format of the first session, where each of the panelists, they gave their comments over 3 to 5 minutes. So I would put it as 5 minutes. And then in the second, I will come back with further questions. So first, I request Captain Rahul Chaudhary to give his remarks.
Okay. Thank you, Mr. Indra Bose. Yes, it's a pleasure to be here to attend this Future Fuels webinar organized by Ramprasad and his astute team. So thank you very much for this invitation. My first thought with Future Fuels is that we should not forget where we are with existing fuels, primarily because this dominance by existing fuels in shipping will be here with us for quite some time to come. Now, international shipping uses more than 300 million tons of this fuel every year, which powers more than 55,000 vessels out in the oceans as we speak. So this conversion is a massive task ahead of all of us, as rightly mentioned in the earlier panel discussion as well. As Mr. Anil Devli said, it's quite a minefield, and I would say that's a mild word. The IMO regulations for reducing the sulfur content in fuels to 0.5% was implemented in 2020, as we know. But this was understandably completely overshadowed by the emergence of the COVID that year. In fact, shipping adjusted to this change well enough, primarily because extensive work had been done over the earlier 2-3 years leading on to 2020. So the value of trial and error programs is certainly important. The existing marine fuels are now dominated by what we call the very low sulfur fuel oil, or VLSFO. They are not without operational and technical issues. These can exist in many forms, and it is important that they continue to be effectively managed by ship owners and operators. Because if you do not, you will reduce efficiency and increase your downtime. Existing bunker fuel hubs also play an important role as to where this fuel is bought and sold. Presently, the top 5 hub ports in the world are Singapore, Fujairah, Shanghai, Rotterdam, and Busan. This is important because the key hub ports for decarbonization of the future, what we may call the green lanes of the future, could well follow this trend. So how these large hubs, ports evolve is important. In this context, where India port stands is important to keep in mind. Presently, India's portion of the global bunker or the marine fuel share is very small at about 2%. My second thought is on the options available for us as future fuels. There's no panacea for the future, and all future fuels come with its own pros and cons, be it ammonia, methanol, or hydrogen, etc. So for example, whereas they can reduce the CO2 emissions by 95 or 100%, they come with various other limiting considerations like safety. Ammonia is highly corrosive in nature, and methanol has a very low flash point. For those who may be interested, methanol's flash point is very similar to gin. I mean the drink, gin, because it's about 10 to 15 degrees centigrade. Both have energy densities, half of existing fossil fuels, so you'll need to have much larger storage capacity. So there's no free lunch. And none of these are ready today, as this is very much in the discussion and development stage. So as far as the mass use is concerned, one area of interest we see in the short term is in biofuels. This has picked up considerably, especially last year, and does offer us interesting decarbonization options as a drop-in fuel, as it needs no retrofit and can pretty much be used as marine fuel with existing ships and engines. Yes, there is talks of sustainable biofuel, but this is changing with the second and third generation biofuels, which are not necessarily crop-based. Lastly, for decarbonization in shipping to succeed, there is a need for creative collaboration, robust R&D work, and a regulatory framework that encourages and supports such a direction, be it in a port or a state or a country level. Singapore has all three in one, and in fact can offer interesting ideas and works in progress in this respect. Thank you.
Thank you very much for being within the allocated time. So now I give a request, Mr. Jairaj Kumar.
Yeah, thank you, Mr. Bose, and thanks to Gateway Media. So while a lot have been said about reduction of GHG emissions from ships, there is very little which is talked about the port segment, which I probably would like to represent to the forum. As we're all aware, IMO is the regulator for ships for reduction of GHG gas emissions. Unfortunately, there is no regulator for the port segment, and ports are equally responsible for reduction of the GHG emissions. Member states have signed the MEPC 74 resolution, which talks about cooperation between port sector and the ships to reduce GHG emissions from ships. There is nothing which talks about the reduction of GHG emissions from the port segment. They have identified 4 areas. One is development of offshore power facilities in ports, preferably from renewable resources, provision of safe bunkering facilities of low carbon or zero carbon fuel, promotion of port incentives for ships causing low emissions, and optimization of port costs. Having said that, India in specific has a few action plans which have been announced. One is, of course, the India Maritime Vision 2030, then the National Action Plan, then key interventions and green initiatives to support the National Action Plan, and the commitments which our country has made at the COP26. In fact, in the National Action Plan, what has already been included as policy initiatives is to have just-in-time arrivals at ports by 2023, and also port-based incentives for low-emission ships. In the infrastructure segment, they have identified battery charging stations at ports, bunkering stations for LNG, ammonia, and hydrogen. And in the technology and solutions segment, they have identified shore power to all by 2023. So these have been the action plans which have been initiated. But having said that, as a brief introduction, I head Ocean Sparkle. We operate in about 30 ports across the country. We are a port service provider. We also operate in a few international ports as well. But sorry to say that although initiative says that by 2023, some targets have to be achieved, there is very little which has been started as yet. In fact, we run and operate tugboats in many ports across India, including some of the LNG terminals in India. And our efforts to bring in LNG fuel tugs, even at these ports, has not met with much encouragement. So there is got to be a regulator for sure. First and foremost, there has to be this thing to measure the emissions, which is not yet in place. And secondly, as I said, there has to be an incentive to convert. And also, I mean, for a fact, all these measures would obviously mean increased capital cost, which necessarily has to be supported in some form, like a viability gap funding or something, for us to really look at measures to reduce the GHG emissions. With this opening remarks, I'll pass it on back to the chair, where I'll be open to further questions on the segment. Thank you, Mr. Bose.
Thank you, Mr. Jairaj Kumar. I mean, you identified a very important issue about the port sector. They play a major role in shipping decarbonization, just in time, bunkering facilities, and all the other issues you mentioned. So thank you very much. I will request Mr. Pawan Kapoor to give his initial remarks. Thank you.
Thank you, Mr. Bose. Good afternoon to everybody. And at the outset, would like to thank Gateway Media for inviting me for this panel discussion. GHG emissions, as we understand, is something which is global. A limited perspective perhaps cannot find us the right solutions. Because GHG, the way IPCC 6 reports talks about, is going to probably even affect our existence in many parts of the world. So that's why, while yes, regulations are to be there, we are working towards new fuels, but the awareness about the seriousness of the situation needs to be really brought down to all the levels of our society in general. And unless we do that, probably will not find the right solutions. We have been involved largely with the training and research activities for the last 17, 18 years. And we also hold a confluence which promotes research. And we see the need for authentic data, because as Mr. Jairaj rightly mentioned, if we really want to reduce the emissions by X, by so-and-so year, by so many percentages, we need to have robust systems of measuring the emissions. And so what is needed is good measurement. What is needed is awareness at all levels. And that awareness, perhaps, though it is difficult, has to go beyond the regulations which are imposed on us. I mean, as human beings, we have to see what is really good for humanity as a whole, what will ensure that we exist, or rather we coexist along with other forms of life that is there. And that's why, perhaps as we discuss further, even the new fuels, which is so important because the existing methods will only be able to reduce the to certain extent by improving the efficiency, so on and so forth. As we explore new fuels, we will have to ensure that we find fuels and extract to an extent where everything still remains sustainable. So with these opening remarks, I would thank you all once again, and probably will be able to share more thoughts down the line. Thank you, Mr. Bose. Thank you.
Thank you. Thank you very much. So next, I will request Mr. Girish Sriraman to give his opening remarks.
Thank you, sir. Well, I think quite a few of the comments have already been given by Captain Rahul and Mr. Jairaj and Mr. Pawan Kapoor. But so what comments I'm going to give is sort of largely echoing what their sort of sentiments. So just to, come back the situation we are in, as Mr. Rahul had mentioned in the beginning, we were all patting on our backs that we managed to get out of this 2020 sulfur regulations. But, before that got over, we are already now looking at these decarbonization requirements coming in. I think the enormity is that, possibly that, as we look at the past, generally we would have a 20-year gestation period, where regulations would be discussed and then adopted, but that's not the case anymore. We are now talking about within a period of possibly 1 to going towards 2030, we are talking about steep what shall I say, carbon footprint reductions as far as ships are concerned. Of course, so that means we have to basically, we are sort of forced, when we are talking about regulations perspective, it has been more like a lot of learning feedback mechanism that used to go into making of the rules is not a luxury in this case. So so that means we have to have a huge collaborative approach across the board, as Mr. Rahul had mentioned. We are talking about regulatory bodies, designers, manufacturers, shipyards, ship owners, charterers and financial institutions all have to come together to make this happen. Of course, when we are talking about going to the nitty-gritties, we are, of course, talking about several portfolio of fuels, towards meeting the 2050 targets. It's not like we are looking at one particular fuel and decided that that's going to be the way forward. We are talking about biofuels, methanol, ammonia, LNG as possibly a transition fuel, fuel cells, and hydrogen. So when we talk about methanol and ammonia, which are sort of touted as possibly the biggest ones, or possible bigger, which will have a bigger stake as far as marine fuels are concerned in the future. Both are coming with its challenges, and as Mr. Rahul rightly put in, possibly methanol is a little bit more easier to transition into as a fuel, but then there are availability issues. But having said that, it also has got it has got a low flash point and it's toxic. So there are technical aspects that have to be taken into consideration, and more importantly, I think the aspects are related to human element, as Mr. Pawan had addressed. Are we there, when it comes to the training related to handling of these fuels, how the bunkering aspects have to be taken into account? These are all, what shall I say, quite a lot of things to be done in pretty short span of time. Then, of course, organizations have to start gearing up. I'm talking about shipping companies and managers, charterers into making the fuels available, and have they taken into account that all these management of change aspects are addressed, and the risks are addressed properly. So quite a lot of, we are talking about a wholesome systemic approach, looking at human, organizational, technical factors, which have to be addressed if we have to succeed. So largely, that's the point that I wanted to make. So over to you, Mr. Thus.
Thank you very much. Thank you. Class plays a very major role in this transition. So thank you very much for your initial comments. I'll come back to all of the panelists with my questions. Now it's over to you, Mr. Christian Mugginson. You can make your presentation. I understand you have a presentation, so please.
First of all, thank you very much for inviting me to speak to this at your webinar, Gateway Media. This is much appreciated. And we also in Main Energy Solutions find that the decarbonization agenda is very important. When we are looking at the industry as a whole, at the shipping sector as a whole, then we can actually see that that we are transporting 80 to 90% of all global flights. And again, the shipping industry is contributing with approximately 3% of all the global CO2 emissions. And when we take into account how many of these vessels that we are actually powering with our engines, then we can actually say that we, to some extent, are responsible for 1.5% of the global CO2 emission. So with this in mind, then of course the journey towards a carbon-free future is also very much on our mind, and this is a goal for us to be able to provide solutions where we have less carbon emissions. And the journey for let's say a carbon-free or a less carbon-intense industry has gone on for quite some time now. We had our first MEGI, our first LNG engine in service in around 2011. And in 2012, we could see that approximately 1% of all the power ordered for vessels for main engines were with dual fuel engines. And and we saw, let's say, not so much movement in this before 2017 and 18, where we started to see an increase in dual fuel engines out there in the market and on order. And when we are looking at 2021, then we actually had around 30% of all contracted gigawatts was with dual fuel engine technologies. And it is our expectation and prediction that the share will increase over time. And that is in order to have a less carbon intensive engine. In January this year, actually 50% of all new building engines ordered was with the dual fuel technology. To give us a small overview of what kind of solutions that we are providing from Main Energy Solutions. In 2011, as mentioned, we started with our MEGI. 2015, we started the development of the methanol engines, and the first methanol engines came into service around 2016. And then it actually just increased, or the time span between we issued new technologies were reduced quite significantly. So also in 2016, our ethane engine came into service, and we started to develop our LGIP in 2018, and we had the first in service in 2018 as well. And now with the LNG market, LNG carrier market, we saw the need for developing a Otto cycle low pressure LNG engine, which where we now have 110 on order, but no engines in service yet. And our latest development is the ammonia engine. We started the work in 2020, and we expect to have the first engine in service in 2024. In parallel to all of this, retrofit is something that we have done throughout the time, where we started with Nake Lab in 2015, and then we have done quite a number of retrofits since then. So to have an overview of a more simple overview of the engines that we are providing, we have our LNG engines, which is currently offering, let's say, a 20 to 25% CO2 reduction compared to conventional fuel, heavy fuel oil, that is. Then we have our ethane engine, which is a sister engine to our LNG engine, where we have gas injection to the combustion chamber. And then we have our series of liquefied gas injection engines with the methanol engine, where we are now at the third generation of this engine, where the first was introduced in 2016, LPG engine, and then our ammonia engine, which is still very much under development, but we have committed to have the first on order in 2024. So where to go and how do we see the future? Because as we just heard, we are currently moving into a very, very interesting period where the decarbonization is a very hot topic and is also a fast track topic, so to say. We see a lot of regulations coming into force now, both from IMO, but also EU just issued Fit for 55, which also have a great impact on how we can operate the engines moving forward, as well as we are seeing owners that are proactively would like to reduce the greenhouse impact beyond what is required from any kind of regulations. And that is because the owners now start to see that there is customers for, even though that there is customers for chartering the vessels, even though that we are seeing a higher OPEX and a higher CAPEX because we are using or utilizing the new fuels, as well as we are seeing finance institutes with the Poseidon principle and others that are only interested in investing in, let's say, greener engines. We at MAN we are a service provider, so we are listening to the market to see what the market is requiring us to develop, and we are in this really trying to keep up with the demand out there, which sometimes can be difficult. Yeah, so there's a lot of inputs. What comes first? Which will be the future fuel? The way we see it is that it very much will depend on which type of vessels that you have, which freight you are on. Are you in a container line between Europe and Asia? Then maybe one fuel could be fit for you. Are you operating in the spot market with a multi-purpose carrier, a bulk carrier? Then there will be different fuel requirements. But regardless of how which fuel that will be the future fuel, then we can say that we have the solution in place already. Looking at the crystal ball, our crystal ball department is only a very few amount of people. So we are very much leaning on the big players in the market, for instance, DNV. And DNV in 2019 issued this maritime forecast where they had, I think, 10 or 15 different scenarios for the future. And whereas when we look at the end result in 2040 and 2045, then ammonia will be the predominant fuel. We do not believe that it will be so black and white. We believe that it will be a mix of all of the fuels. But when looking at the list of the possible future fuels, then we can actually say that our engine technology can operate all of them, of course, besides the electrical grid. What comes first? And of course, this is with all of the inputs to what the future fuel is. There's still a lot of uncertainty. As of now, methanol is a very popular future fuel, so to say, but currently there is the infrastructure for bunkering methanol is very weak throughout the world. So our approach is also that we would like to be able to supply the main engine, and then at a later stage, it is possible to refit or retrofit to any given technology that we have in our portfolio. And currently, when we are looking at the reference list of conversions that we have, then we have done from conventional MEC engine to GIE, ethane engine, conventional MEC engine to LNG, GI, as well as we have done a batch of 15 vessels from MEC, conventional engine, to LGIP. Currently, we are also looking at the methanol projects. We have, let's say, some hot leads, as well as ammonia, of course, also will be possible to retrofit in the future. That was what I just had for you today. And the closing remark, we see a high demand from the end customers, and we see it possible. And we are, of course, keen to listen to the market, what they are telling us and what the next engine technology should be. Thank you.
Thank you very much, Mr. Morgenstern. Excellent presentation. And I mean, we need assurance from engine makers because you are at the heart of things apart from shipbuilders. So thank you very much. I'll come back with questions at a later stage. So, Ms. Vinita Venkatesh, I understand you are in a very different time zone. Is that right?
Yeah, that's right. So I'm in a very cold and snowy Chicago, and it's 1:30 in the morning.
Okay, I can imagine your situation there.
Please excuse the lighting. The lighting in this hotel is not very good. So if you will permit me, I will just quickly put up some slides in exactly the 5 minutes.
Please go ahead. Please,
So I'm going to talk to you again about fuel spec, which Mr. Jitendra has already spoken about, but from a little different angle. So I'm heading a company called Ocean to Door, and Ocean to Door is part of the Vishwa Samudra group. And we have the responsibility of the global marketing and distribution of the fuel spec catalyst. So, fuel spec is actually manufactured in the United States by some scientists. And I'm going to share with you some of the work that they have done and some of the results that they have on the trials that they have conducted. But before that, just to set the context for what we are going to talk about, we've heard a lot in this, all the comments have been resonating at the same frequency, that there is not enough time. There are a lot of new technologies, all of them need to be tried and all of them are expensive. So if you look at the picture in the lower half of the screen, what are the solutions that are available today? Most of the solutions involve high investment. And the only solution that is there in the short term, right away ready for the shipping lines, is perhaps to optimize speed. Now, all of us are aware in today's global supply chain situation, slowing down the vessel is tragedy, not only for the shipping lines who are desperate to carry more cargo, but also for the customers who are already facing so much congestion. And this is what then brings me to fuel spec, which is, I believe, a revolutionary product that has been invented in the United States. Now, these are some of the trials that have been conducted by the scientists who invented fuel spec. So number 2, number 3, number 4. that is Matson navigation on a manned B&W engine, Bahari ship management on manned B&W, and Shipping Corporation of India on a Wärtsilä engine. These 3 tests were conducted by the manufacturers when they were testing to see the results of their product. And you can see some fantastic fuel savings, almost unbelievable kind of results, which of course are came about with a lot of practical trial, as well as a lot of mathematical calculation on the vessel loads and the currents and wind speeds and all of that. After that, when we were approached by the manufacturers to undertake the marketing and distribution, we have done a trial on the SSL Mumbai, again with the same fabulous results, and therefore decided to sign up with them. And now here we are trying to reach out to the industry and every stakeholder in the industry to try out the product. So we have recently, after signing up just less than a year back, done a trial on Jaldi shipping with a 7.5% reduction in fuel saving. And we have also now a trial which will take place shortly next week with the ISL Star, which is part of the Tata Group. So, you know, one part of emission reduction is the kind of fuel that you use and perhaps the additives or the catalysts that you add. And the second part is also reduction in the quantity of the total bunker consumption, right? So I've just put here some numbers because it's finally whatever we have to do in technology with the technical departments and however we run our ships, finally, it's all about money, because every enterprise has to be economically and financially viable. So fuel cost represents a significant percentage of the operating cost of a vessel. And today, you know, I have put here the fuel cost as $750 per ton, but it's already at $775 or $780. And with the whole Ukraine crisis happening, we can't really say where the fuel cost will go. So if you consider a 10 days in port and steaming of 20 days with a 35 tons per day consumption, we are then looking at a sensitivity analysis. If you have a 7%, 8%, 9% reduction of almost $20,000 on one vessel, 1 month, the economics is very, very startling. And even if we don't get 7%, even if you get 5%, it's a massive saving. So just to give you a quick look at how the trials are done, the dosing ratio is 1 to 4 tons. Depending on the appetite of the customer, the trial can be for 15 to 30 days, and then the data is recorded and analyzed. And this is the trial that we did on Jal Kumud. A very simple dosing on board by the vessel crew, at least for the trial. And for the emissions reduction, we have we can use these handheld machines that can capture the readings. So some questions that keep coming up from people is, you know, we want to clarify that fuel spec is a catalyst which makes for fuller combustion, and it's not an additive. It is not proposing to replace the working of any of the additives that the vessel's technical teams might be using right now. And it is also not going to interfere with the working of any additive. It doesn't impact the engine because it's a pure catalyst and no deposits. It can work, of course, with scrubbers because scrubbers have a different purpose. It can be used on both 2-stroke and 4-stroke engines and stored for long periods of time. And yeah, this is just our contact list. So that's all I wanted to say, just to introduce the product, and then I'll come back with any other comments.
Thank you very much, Ms. Vinita Venkatesh, and very informative and efficiency improvement. I mean, until we go into the other lower and zero carbon fuel will remain a matter of great assistance to shipping. So I'll come back with questions at a later time. So having gone through the initial remark, now I come back to the questions. So first question I have to Captain Rahul Chaudhary. You did mention about the 2020 change that happened, and you have been testing. What has been it has been comparatively smooth than what we had expected. So what were your findings with respect to fuel quality post 2020 and the biofuel part? I mean, there are biofuel tests are happening. So if you have tested biofuel, and how do you see biofuel as a solution? Thank you.
Sure, thanks, Mr. Bose. A pleasure to give a little bit more elaboration. Yes, I mean, the way we see it, there was a lot of planning, preparation, testing by owners operators pre 2020, and I would think based on what we test, I think it has been a smooth transition. And one of the ways to look at it is to say basically the IMO regulations is about reducing the sulfur content in fuels. So has that been achieved to meet the 0.5%? I would say yes, it's been achieved. It doesn't mean that there's been no issues. What our data shows is that about 3% of global fuels are off specification in sulfur. We don't think that is a huge amount of sort of default, but I think we need to keep that in mind because if that happens to your ship or you're operating the ship, then you have a dispute and an issue to handle, and that's one aspect. The other aspect, if we look at a macro level on fuel quality, as we stand today, about 6% of global fuels are off specification on one item or the other, instead of going into, and the primary reason is because the VLSFOs are blended fuels. And some of the common fuel quality issues we see with these new blended fuels, which is quite different from pre-COVID days, are issues like fuel stability, which is linked to the way these fuels are blended, which are again linked to technical issues like filter clogging, sludge formation, etc. These fuels tend to have cold flow properties, as we call it. So they need a certain level of heating, and you want to be very careful if you are, navigating in cold waters. They have what we see high cat fines or higher water levels that we've seen this year. So basically, good housekeeping is needed on board ships and the way you operate the ships, and you need to keep that in mind. One interesting aspect I did want to touch on is how do we see the distribution of these problem fuels with VLSFO so far? Very interestingly, the VLSFO problem fuels are much more in Europe and the Americas than in the Asia Pacific. I think that is quite an interesting finding. I don't have the exact reason why it's happening. Maybe it has to do with the fact that the COVID has reduced the supply chains and products are not moving across borders as much as it was before and the way it's blended. So that's, I think, an interesting observation. Going on to biofuels, yes, especially last year, we've seen the amount of tests we've done on biofuels dramatically increase by possibly 5 to 10 times that we've ever done before. There are many big ship owners and operators who've already completed a number of trials. Some of you guys who are very active on LinkedIn will have seen a message or a post by CMA CGM yesterday that they're going to trial biofuels and working together with the Maritime Report Authority of Singapore on 32 of their large container ships. And they're going to burn a biofuel called B24 because you can get biofuels from B10 to B100. And approximately what they mentioned in the article of yesterday is that they'll get a 21% reduction in CO2 emissions. And we see that with other ship owners as well. if you are going to pick up a B25 fuel, which means 25% of biofuel which has been blended in, you're likely to see about 20% CO2 reduction. It's an easy fuel to use. It complies with sulfur regulations. It has a pretty good energy value, close to a pure fossil fuel. It has good ignition and combustion characteristics. But I'm not going to say that it is sort of, it's going to solve all your problems. You do need to be careful of things like oxidation of this fuel. You need to be aware that you probably can't store it for too long. It needs to be used up quickly because of bacterial growth or cold flow properties. And I would add that a number of engine manufacturers have actually got biofuel specs and biofuel recommendations very much in place. So, I mean, from our point of view, we will probably test whatever you want us to test, but we do see a lot of activity in this area. Thank you, Mr. Bose.
Thank you very much. Thank you. I will now turn to Mr. Jairaj Kumar, that you are in the port sector very much. And what kind of, how do you see the port sector preparing themselves for the transition? And another question is, as a ship owner, I mean, what all the things you have done or you are looking at in decarbonization?
Yeah, thank you, Mr. Bose. In my opening remarks, I mentioned that we haven't yet got started, but definitely there are action plans which have been made, and ports can contribute both directly as well as indirectly for reduction in GHG emissions. Directly, one of this thing is to increase the use of renewable energy to greater than 60% across major ports. I really don't know why they say major ports only, because today minor ports contribute an equal amount of cargo handling. I think that needs to be looked at. Drive adoption of multi-clean fuels like electric, CNG, LNG for port crafts, as well as for vehicles which are used in the ports for moving containers, moving cargo around. Electrification program for material handling equipment in ports. Build a real-time monitoring program to track key HSE KPIs in ports and shipyards. So this is very important to reduce the GHG emissions. And these are the direct contributions which the ports can make. The second is, how can the ports support shipping in reducing their emissions? One is to provide ship-to-shore electricity for all vessels, first starting with tugboats, then going on to coastal vessels, and then exim trade vessels in a three-phase targeted manner through an intermediary who will provide this renewable energy power. Establishing LNG bunkering, ammonia bunkering, hydrogen bunkering facilities at ports. Increase the use of efficiency enhancement techniques such as ship tracking and smart lighting at ports. Use big data to arrive at just-in-time arrival for vessels at ports. And monitoring facility to check the quality of emissions for vessels in port and incentivize them accordingly. I see a question in the chat box where somebody made this thing, and of course, Mr. Christensen also pointed out that ships are only responsible for 3% of the emissions, and what are we talking about, kind of thing. Well, I do agree with the questionnaire about what he's saying, but it is not without reason why we are trying to attempt this. And everybody here will certainly agree with me that unless and until there is pressure to this thing, nobody wants to change. And in my case, the pressure is from the financial institutions and private equity investors who are, especially multilateral financial institutions like IFC and ADB, who have clearly spelled it to us that unless and until you show progress in going green, we're not going to fund you anymore. So that's the reason why we are looking at change, quite honestly, right? The second question which you had was, how are you as a company progressing with the green initiatives? Yes, we are the largest tugboat operator in the country. And we've already have identified a biofuel, which is a complete replacement for the hydrocarbon or the fossil fuel that we're going to use. We're going to test this biofuel shortly. It is from agricultural waste that this biofuel is being produced in India by a company called Green Jules. And we're going to try that fuel on our tugboats, number one. Number two, given the fact that there is a lot of idling time on a tugboat, it has been proven beyond doubt that hybrid tugs are a good answer for reduction in GHG emissions. In fact, there are recognized designs for hybrid tugs where the actual power requirement comes down substantially for the same bollard pull which is going to be required for the tugboat. So we are in advanced discussions for construction of hybrid tugs. And I do hope that the port sector till today, which has not really woken up, we are actually being sandwiched between the port sector and the financial institutions. The port sector, if it can give us some leeway, where it not only judges a tender by just the charter rate that we are giving, but by a combination of the charter rate and the savings in fuel that we can bring in, and which they can obviously, fuel is being supplied to us as a pass-through. I think we can definitely make a start in getting into hybrid tugs. Thank you.
Thank you. Thank you very much. Mr. Ram Prasad, and I suppose somebody is taking note of the suggestions and recommendations being made by the panelists. Very, very valuable in this transition. I now turn to Mr. Girish Sriraman. You are a classification society and responsible for safety, security, and environment protection of ships. So what all gaps do you see in transitioning to the lower and zero carbon fuels, and how are these being addressed from the classification society perspective? Thank you.
Yeah, as I said in my opening remarks, sir, I think we have to categorize it into possibly into three aspects. One is, of course, the technical aspects, then, of course, the human element, and then, of course, the organizational part. I suppose, when we talk about the technical aspects, it may possibly, what shall I say, you invest in money and CapEx, I think, possibly the easier part to handle. Of course, the challenges that are happening at this point is basically we have a wide, it's not like we are looking at one particular fuel, we are looking at several kinds of fuels at this point. Of course, then when you are talking about technical aspects, it's from a classification perspective or from a statutory perspective, then what we are looking at is basically addressing the regulatory aspects and the design aspects, looking at all the design aspects and framing the rules. Of course, as I mentioned in my opening remarks, we have generally been in a phase where we used to get possibly a 10 to 20 years of, what shall I say, a hearing phase before regulations, used to come into force, but that's not a luxury that we have at this point. So when we are addressing, again, when we are talking about methanol, ammonia, or LNG, or hydrogen, when we look at the existing vessels, none of them can take on board any of these fuels, because of the flashpoint issue. Then, of course, toxicity, depending upon what fuel we are talking about. So, so the immediate aspect is if owners are looking at retrofits, maybe it may not be financially viable for most of the fuels, and possibly, yes, some of them it may be possible, but for most of them it may not be financially viable. And then, of course, the other aspects, then we are, if we are, those are aspects related to the technical aspects. Then, of course, the aspects then that we have to look into is on the competence part. I think, again, Mr. Pawan Kapoor addressed it. Are the ship staff on board, are they, what shall I say, have we addressed all the training requirements which are required to ensure that the competency is there to handle these fuels? And so, and then, of course, the organizational aspects. So quite a lot of things have to be looked into and in a sort of a broader picture. If we have to see that all these gaps are addressed and we are able to take on board these fuels in a safe manner. I hope I have addressed the question.
Yes, thank you. So the question I have for Mr. Pawan Kapoor is that if you can tell us something about, I understand you are involved in a Green Voyage 2050 project of Norway, IMO, Indian government. That can you tell us about it? What is happening here with this particular project?
Thank you, Mr. Bose. While I may not be at liberty to share specifics of any discussions with the stakeholders, but I'll certainly, for the benefit of the audience, give a broad picture. Essentially, the Green Voyage 2050 is a collaborative project where Green Shipping Program of Norway is the supporting organization. Green Shipping Program, as you may be aware, was formulated in the year 2015. And they are essentially a public-private partnership program in Norway, which involves the government, the players, the manufacturers, and they are essentially trying to do studies, take up projects, pilot projects, implement some of the ideas which they are deliberating upon, and thereby find green solutions. So it's a very customized kind of an approach to finding green solutions. Now, with the help of GSP, who have supported IMO and the DG Shipping, I'm there as one of the consultants in individual capacity, along with my colleagues. And essentially, we have industry players who have shown interest in adopting green technology, with whom we are having a dialogue and trying to find out the situation that they may be in. And thereby then studies will be carried out to find suitable green solutions. Now, these solutions obviously will involve new fuels and technology, but also keeping in mind the impact that such implementation would have on the society at large, because there are other stakeholders who get impacted. Incidentally, I would just like to share something here, that even the IPCC 6 report actually gives a correlation between the mitigation measures to reduce the GHG emissions and the various sustainable development goals. Because any mitigation measure is also going to impact positively or adversely some other part, some other entity globally. So that's why in this particular project, implementation of new technology or ideas would happen as a result of a comprehensive study to evaluate what would suit in which context, basically. So that's the whole idea behind this project. Thank you.
Yeah, thank you. Absolutely, you are right about this. The sustainable meaning of sustainability, just not priority on one's issue. There are other sustainability goals as well. So thank you very much.
Thank you so much.
I try to, as Vinita Venkatesh, so you have been involved with the 2020 sulfur cap changes, and so do you see some lessons that we can learn from that change with respect to the changes in fuel to, there's decarbonization? Do you see any lesson to be learned, and what are the impediments or you can you find, and what changes are needed? Thank you.
So, from my experience in talking to many ship owners, technical departments, etc., time is ticking. And maybe because of COVID, we all forgot the kind of stress, urgency, and absolute chaos and confusion that everyone went through before the 1st January 2020, when there was so much evaluation to be done, and the cost implications, the most important cost implications to be considered. Right now, yes, again, the 1st January 2023 calendar date is here coming up upon us, and ships, as you know, are mysterious entities. The VLSFO adoption has not been easy. So many quality issues with the fuel supply. And there was one customer who said to me, "Madam, if your fuel spec can just reduce the deposits on my engine, I'm happy. It doesn't matter whether I'm going to save money on fuel efficiency or not." So I think that there are some, perhaps we need to adopt a different approach than we have adopted in the past to new technologies, new suggestions, because everything needs to be tested, right? There is nothing that we know is for sure going to help us. Everything needs to be tested, and very importantly, the ball is not only in the ship owner's court. So in the ship owner's office, what I observe is happening is that the technical department and the commercial department. So if the technical department is, let's say, in the case of fuel spec, has gone through all the chemistry, all the documents, all the exhaustive trial reports that we have, and then there is no budget. They don't have budget to do the trial. So then you have to go to the commercial department, and then we start the ball rolling again. So I feel that if we are internally more cohesive and realize that this is a common objective, of course, everyone realizes in the bigger picture, but in terms of the actual work description or the job description of each department, perhaps it can help if this changes. And also the ball is not only in the ship owner's court, like I said earlier. So many other agencies are involved, and many customers say to me that, "Oh, we can't test your product unless you get me an engine manufacturer's NOC." And I don't have to tell you what will happen if I go to an engine manufacturer. So I think that engine manufacturers, insurance companies, all other statutory agencies, we need to relook at the cost element of assessing any new technology. And I feel there should be a more participative approach when there is some new technology. If fuel spec, if like the inventors say, and like our tests are showing, is actually going to reduce the fuel efficiency by 10%, then it's something that everyone should be engaged in, right? It's, to my mind, it feels a little bit strange that we will spend $500,000 on retrofitting an engine for a 2% reduction in fuel consumption. And if there is a product for which a testing involves only $20,000, it is, can you give me free samples? No, to test it on my engine, it will take 300, I don't know how, very high cost. So I feel that there has to be a little bit of, like I said, a participative approach when somebody is approaching with a new solution or something that can reduce the emissions and reduce the bunker consumption. Similarly, if ports can give incentives like also what Mr. Jairaj was saying, cargo owners again have to be participative and agree to bear portion of the cost. And in this, perhaps a lot industry associations can also support. There are many industry associations who need to start educating their members about this global responsibility that we have. It's not just about the ship owner or the shipping line who is carrying our cargo. We are also part of this whole enterprise to kind of save our world, and we must be prepared to bear part of the cost. So for this purpose, we have been Fuel Spec. We have been doing a lot of promotion and reaching out to many markets. Largest reach out that we have done is in the Middle East, where we participated in 3-4 events just to disseminate information about this product and its promise, and to request shipping lines to on ship owners to try out the product. And then we will also be in Europe in June at the Posidania and at the Decarbonizing Summit. And I request everybody who's on this webinar, please reach out to us. If we can help in a small way, whatever small way we can help, we will be very happy to partner with the industry in its effort to reduce emissions and increase fuel efficiency. So I'm going to stop this share here. So I just had one comment that I wanted to make. While we're talking about carbon emissions, Fuel Spec, it's also shown in the test that it reduces NOx substantially. Now, one of the inputs that I got from the technical director of a shipping company was that today we are keeping the combustion pressure lower in order to reduce NOx emissions. Now, if Fuel Spec is supposed to reduce the temperature peaks and make for a more even temperature during the combustion process, and thereby it reduces NOx emissions. So this could actually help the industry, because then you don't have to reduce the combustion pressure and you can allow the vessel to steam faster. Also about biofuels, my understanding is that when you use biofuels, the NOx emissions are more. I don't know if this is correct, but if it is, then again, Fuel Spec can be a very valuable possibility for even ship owners who are planning to use biofuels. Of course, all this has to be tried. Thank you.
Thank you. Thank you very much for the information. I now thank each of the panelists for their excellent contribution and making it useful for our viewers and even individually ourselves. And I know there is question for Mr. Maukelsen, so I will hand it over to, in the chat box, and it is there, I have seen it, so I hand it over to Mr. Ram Prasad.
Thank you, Mr. Bose. Yeah. I will just read out these questions. Some are addressed to specific panelists and some are general. So the first question is, what is the opinion of all the panelists in regards of changing the rules of construction to ensure net zero vessels will be built post 2030?
So IMO has sort of moved towards a goal-based approach. So they have left it to the industry, the ship owners, to come up with solutions. It's we are moving away from a prescriptive approach to, what shall I say, a goal-based approach. So as we come up with solutions, and the spirit of what is required to be achieved is fulfilled, rules are getting framed.
Thank you. There are two questions to Christian Morganson. The first question is, would you please elaborate on the storage material requirement for the tank construction, also pressure and temperature condition for storage of ammonia as a fuel?
Yes, so ammonia, we expect to store it at in liquid phase, so that will be around minus 35 degrees. Probably here we will have some safety margin and then store it at an even lower temperature. In terms of, let's say, the tanks and the tanks' capabilities, then of course ammonia is a corrosive fuel, it's a corrosive material, and this sets some requirements. However, what is a very big advantage for us in the marine sector is that ammonia is already now widely used in the process industry. So what we can do is that we can actually adopt, let's say, the regulations and the guidings from the process industry to the marine sector. So that means that we know that we will be using a 316L stainless steel, as well as we will adopt a mixture and let's say a fuel spec which contains 5% water, and that is in order to avoid stress corrosion. So in general, yes, ammonia is a new fuel for the marine sector and a new fuel for marine sector. However, ammonia has been handled for many years as fertilizer in the process industry. So with this, we can really adopt on the knowledge and know-how from the process industry. I hope that replied the question.
Yeah. The second question is, can you please say something about your newly developed low pressure MEGI engines with reference to methane slip? For your methanol and ammonia engines fuel systems, is this being designed by the shipyards or man? The cost for the engines, are they as high as the fuel systems that have to be installed?
Yes, and thank you very much for this question. So we at MAN, we designed the engine and we also designed the specifications towards how which temperature and which pressure and which amount of in this case LNG should be supplied to the main engine. And from this point on, then it is up to the owner to select a maker for the fuel gas supply systems. That is not what we do. So this is very much dependent on the yard and the engine builder together with the owner to decide which maker they should use for the fuel gas supply system. And again, this is also very much dependent on which kind of LNG carrier you have and which kind of principle that you're using for cargo handling. The engine price, what we saw with the MEGI was that the engine price was almost similar to the reliquefaction plant for the LNG. And that was again because of the setup, how the yard decided to handle the cargo, where we would like to reliquefy a lot of the LNG. With the MEGA, the fuel gas supply system is a bit more simple because we are only requiring 12 bars of inlet pressure to the main engine. And to briefly touch upon the methane slip, because we're using the Otto cycle principle, we have slightly higher methane slip compared to our MEGI with the diesel cycle principle. However, with our MEGA, we have installed EGR as a requirement, and this will actually contribute to reduce the methane slip with around 50%.
Thank you. This question is to Rahul. Rahul actually addressed Arvind Sharma's question, but this is a subsequent question. Has Veritas tested different sources of biofuel? I'm aware that testing to C14 bio content can be measured as done for 80 to 17 parameters. Will this, in your opinion, be required to be verified, notwithstanding BDN, etc.?
Yeah. Thanks, Ram Prasad. I saw that. What we are saying is that since biofuels is an addition to existing fossil fuels, ISO 8217 is the existing fuel quality standard. So it would be smart for one of the operators to follow that. If you're a first user of biofuel, it would be good for you to do additional tests such as FAME, which is what biofuel is made of, fatty acid methyl ester. you need to do a copper corrosion test. You need to make sure the ignition qualities are good, etc. I think in the initial phase of using of biofuels, especially during a trial phase, is really important. You sort of add on to existing test methodologies just to make sure you have a good feel of what this product is, irrespective of where it comes from. We are seeing biofuels, generally they have given the notation B. So you can have B10 means about 10% of biofuel to B100, which is a pure biofuel. What I would add, Ram Prasad, is that if I use the example of CMA CGM, yesterday's news that they're going to burn B24 UCOM. What does UCOM mean? It's used cooking oil methyl ester, done in a sustainable way. So they're also trying to, the way I see it, sell the idea that it's sort of a circular economy. You're not sort of burning crops down. So that would be my comments. Thank you.
Thank you. This question is to Mr. Jairaj, a subsequent question by Arvind Sharma. What is the standard to which shore power is being installed in ports? So this is purely from a line operations perspective. And another question is, can ports implement any measures without the government regulations and support financially?
Okay, and the shore power at ports which is being given is 50 cycles 440 at the moment. As I said, the action plan is to provide this power from renewable sources, but for the moment, it is from line sources that it is being provided, number one. Number two, without the government support, can ports do this thing? For sure. I mean, as I said, most of our contracts, the fuel is supplied by the ports, and if ports do agree to supply biofuel instead of fossil fuel, directly would this thing into reduction of GHG emissions. And as I mentioned, use of either electric or LNG or biofuel for other port crafts and transport vehicles, they can surely aid. And for all this, the government support is absolutely not necessary at all. So ports can very much do a lot, and they don't need to have any support from the government, actually.
Thank you. Mr. Bose, in view of the time available, I have the last 4 questions. Out of them, 3 are to Christian. Okay?
Okay, please.
Okay. So the first question to Christian is, NH3 as alternate fuel, what is the impact on NOx emissions?
Yes, so NH3 is of course a nitrogen-based fuel. And of course, we expect that when we are combusting it, then we will see, let's say, an increased amount of NOx compared to what we are used to with heavy fuel oil, LNG, and so on. So of course, this is let's say, a concern of ours. As of now, we actually don't know the actual number, and that is because we have not been able to do the full test yet of ammonia. But that mentioned, FCR is available as an ambient technology for reducing the NOx. And we strongly believe that we will be able to tune both the engine process as well as the SCR unit in order to cope with the increased amount of NOx in order to be compliant with the tier 2 or tier 3.
Okay. When NH3 as alternate fuel is being used, how engine components are protected against high corrosion to ferrous materials? Do engine cylinders, liners, etc. need modification?
As of now, we don't know, but we expect so. So again, we have not been able to do the first combustion chamber test of ammonia. Once we have this in place, then of course we will have a better picture of the corrosiveness of ammonia. But that in mind, we are preparing to handle a very corrosive fuel, both in terms of what do we do with the piston crown liners and piston rings, of course. When we are looking at the fuel injection system, then we can actually see that we believe that we are on track. Again, this is the knowledge learned from the process industry. So for the fuel equipment system, then we have the right materials in place.
Thank you. Last question of the session to Ms. Vinita Venkatesh. Has the fuel spec trial done for the engines with respect to the carbon deposits in the combustion chamber and the combustion equipments? That is, initial inspection before using and intermittent inspection till the next overall period.
Yes, so we have 3 trial reports, which are very extensive and detailed trials, and we are happy to share those reports with whoever has an inquiry and to dialogue on them.
Thank you. There are some comments from the participants, but of course, due to paucity of time, I cannot read out all the comments. But I thank them for their enthusiasm and interest in participating in the discussion. Anyway, I'll be sharing those comments with our moderator and other panelists, and also take note in our magazine in subsequent issues. With these comments, I hand over to Mr. Indranath Bose to conclude the session.
Thank you, Mr. Ram Prasad. So it was a very, very useful and informative session. And thanks to all the panelists once again. And thanks to you, Gateway Media, for thinking about this, your publication. When I saw the publication, I said this was very much needed now bringing this whole issue to knowledge of all stakeholders. And it's a long journey for us, a difficult, challenging journey, but we can overcome it because for our future generation, we need a place where we can live and not leave the earth like we saw Don't Look Up in that movie very recently. So thank you very much. That's all from my side. Thank you.
My pleasure, sir. So on behalf of Maritime Gateway and Future Fuels, I thank the moderator and all the panelists, Captain Rahul Chaudhary, Mr. Girish Sriram, Ms. Vinita Venkatesh, Jairaj Kumar and Pawan Kapoor, and Mr. Christian Morgensen for their valuable time accepting to be on the panel. And let me tell you, at 1:50, we still have 140 participants logged in. So that shows the interest of the our industry participants to know about the fuel segments and the regulations and the challenges that are coming up in future. So thank you very much. We look forward to much more engaging sessions in future. We will be in touch with you. Thank you very much. And I thank all the participants so patiently have waited from 10:30 to 2 o'clock and participated in both the sessions. And I once again thank all the associations that have supported us, FOSMA, CMMI, and Institute of Marine Engineers, INSA, and Fuel Spec for supporting this initiative. Thank you very much, one and all. With this, I end this session.
Thank you. Bye.
Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.